Let's look at another example of how we can use each of these different terms, each of these different parts of a graph to graph a quadratic function. This time I'm just going to start with the equation. Note that it is in standard form. And I'm going to use each of the x-intercept, the y-intercept, the vertex to put down some points on my graph. When I'm done, I want to have at least 5 points. So if I don't have any others, then I can either use a table or I can use the axis of symmetry as a mirror to reflect points across, those types of things. Let's go ahead and start with the vertex so that we know where the center of our graph will be. And so when we do the vertex, as we learned in the past video, the x value of the vertex is equal to negative b over 2a. Now when I put the numbers in, remember it's ax squared plus bx plus c. Now notice in this case c would actually be negative if I had to put that in somewhere. Of course in this case I only need to put in a and b. So we're going to go ahead and put those in. B is 4, and then a is 2. And so 4 divided by 2 times 2, 2 times 2 is 4. So negative 4 divided by 4 would be negative 1. So that will give me the x value of my vertex. And that's actually also my axis of symmetry. So we're going to write that down. My axis of symmetry is at x equals negative 1. So let's go ahead and we'll draw that in right here at x equals negative 1. Axis of symmetry will be my orange line here going straight down the middle. Okay, I'll circle it in orange so I remember that's what it is. Now let's go back and let's find the y value of the vertex. To get the y value of the vertex, I'm just going to put negative 1 in for each of my x values. And so it'll be 2 times negative 1 squared plus 4 times negative 1 minus 6. So negative 1 squared is negative 1 times negative 1, which is positive 1. 1 times 2 is 2. Minus 4 minus 6. So that will give me a negative 8. And so my vertex will be at negative 1 comma negative 8. Now that's on my axis of symmetry here, negative 1 all the way down to negative 8. There's my vertex. Okay, let's go on to something else. Let's try to get the y-intercept. The y-intercept is usually fairly easy. So to get the y-intercept, do you remember what we need to do? We need to make x equal to 0. And so I'm going to go y equals 2 times 0 squared plus 4 times 0 minus 6, which means that the y-intercept will be at y equals negative 6. So x is 0, y is negative 6. So we'll go ahead and put that on. So 0, negative 6, there's my y-intercept. And last of all, let's go for our x-intercept. Now, hopefully you'll remember that the x-intercept will come when y equals 0. And so I'm going to go and I'm going to put y equals 0. And then I'm going to have 2x squared plus 4x minus 6. Now, you'll notice this time it's not quite as easy. I do have a leading coefficient. However, hopefully you notice also that that is a common factor. So I'm going to start by factoring out the common factor, which will leave me with x squared plus 2x minus 3. This won't always be the case. Sometimes you'll actually have to factor it with having that leading coefficient there. But just for the sake of this one, we've got that. So now we will factor that trinomial, which should end up giving us, we'll put the x's in front, and then I'm going to have a plus 3 and a minus 1. Don't forget the 2 in front. It's still there. Okay. Now from this point I have 3 things that multiply together to give me 0. The 2 obviously can't be 0, but x plus 3 could be 0, which would give me x equals negative 3. And then x minus 1 could also be 0, so we'll go ahead and add 1 to each side. So x is equal to 1. And so let's put our x-intercepts down. We have an x-intercept at 1, and we have an x-intercept at -3. Okay. Notice that they're both the same distance away from my axis of symmetry. They're mirrored on both sides. Okay, now I see that I got 1, 2, 3, 4 points, so I need one more point. What I'm going to do, rather than plug in a number, because I could just pick an x value and plug it into my equation and get another y value for some other point on my graph. But what I'm going to do instead is I'm going to take my my y-intercept here, and the y-intercept is one space over from the axis of symmetry. So I'm just going to go one space over, and I'm going to put another point right there, because that would be the mirror image. Now I'm going to do my final graph here, and I'm going to connect all the dots with a smooth curve, as smooth as I can. Okay, obviously you can't use a ruler for these, so you just do as best you can. And there is my quadratic graph. Again, you'll notice that the vertex, or the x value of the vertex, is halfway between the x-intercepts. And so again, that's something that you can use. Let's try one more example.